Yes, students, let us start with the next topic, foundation. So, let us see to the next topic, types of foundation, students. The foundation may be broadly classified as shallow foundation and deep foundation. Now, students, what are shallow foundation? According to Terzaghi, a foundation is shallow if its depth is equal or less than its width. Okay, students. So, shallow foundation are those foundation which is having its depth is equal to or less than its width. Okay. Next, types of shallow foundation: spread footing, combined footing, strap footing, mat footing, okay, or raft foundation. So first one, what is spread footing now? Spread footings are those which spread the superimposed load of wall or column over larger area. Spread footing supports either column or wall. Okay, so in the spread footing there are different types. Let us see one by one. So first one is, students, single footing for column, in which the loaded area of column has been spread to a large size through single spread. The base is generally made up of concrete. Next is stepped footing for column. This type of footing provided for heavily loaded columns which required greater spread with steps. The base is generally made of concrete. Slope footing for foundation columns. So in this type of footing, concrete base does not have uniform thickness but is made slope. Then wall footing without step. It consists of a concrete base without any steps, included masonry wall. So stepped footing for a wall. It consists of a masonry wall. Okay, we'll have stepped footings with concrete base. These are the pictures of different types of footing. See, students, this is sloped column footing. This is simple wall footing, simple column footing. Next, stepped wall footing, stepped column footing. Till here we have completed in the previous class, right? Next is grillage foundation. What is grillage now? This is a special type of isolated footing generally provided for heavily loaded steel column and used in those locations where SDCE of the soil is poor. So the depth of the foundation is limited to 1 to 1.5 meter. The load of the steel column is distributed over very large area by means of two or more tiers, okay, of steel joint, each layer being laid at right angles to the layer below it. See, students, like this. So this is the iron plate, this is the column, the steel beams, nothing but the grillage. Next, what is combined footing now? A combined footing, a spread footing which supports two or more columns is termed as combined footing. The combined footing are of different types. Rectangular combined footing. The combined footing which will be provided, okay, in rectangular in shape if column carries equal loads. The design of rectangular combined footing should be done in such a way that center of gravity column coincide with the center of footing area. Next one, trapezoidal combined footing. If column carries unequal loads, the footing is said to be trapezoidal in shape. So combined column wall footing. It may be required to provide combined footing for column and wall. Such combined footings are shown in the figure. See, students, if the column carries equal loads, then this is combined. If it carries unequal loads, then this is in the shape of trapezoidal footing. This is having a shape of a rectangular footing. Okay. So here, rectangular, trapezoidal. Next one, students, see here, where we are going to provide with the column as well as wall. This third one, third case. Next, students, what is strap footing? If an independent footing of two columns are connected by a beam, it is called a strap footing. A strap footing may be used where the distance between the columns is so great that trapezoidal footing becomes quite narrow. The strap does not remain in contact with soil and does not transfer any pressure to the soil. Okay. See the picture, student. This is a strap footing. This is the adjoining wall. This is called two columns, column A and B. This is the strapping. This is footing of column A. This is footing of column B. This is adjoining wall. We can see here also. Yes. Next, what is raft foundation, students? So raft foundation is a combined footing that covers the entire area beneath the structure and support all the wall and column. They are used in area where the soil masses contain compressible lenses and the soil is insufficiently erratic so that differential settlement would be difficult to control. Raft foundation may be divided into three types based on their design and construction: solid slab system, beam slab system, cellular system. All the three types are basically the same, consisting of a large, generally unbroken area of slab covering the whole or large part of the structure. See friends, this is a flat plate, this is a section, this is flat plate thickened under columns. This one, section at section BB. Next, see the picture friends. At site, it is constructed in this manner. Next student, what are deep foundation? So deep foundation are those in which the depth of the foundation is very large when compared to its width. So deep foundation may be of the following types: pile foundation, pier foundation, or well foundation. So pile foundation. Pile foundation is that type of foundation in which the loads are taken to a low level by means of vertical members. Okay, which may be a timber, concrete, or steel. So pile foundation may be adopted when no firm bearing strata is available and the loading is uneven. So pile foundation of three types: end bearing piles, friction piles, and compaction piles. What are end bearing piles? This type of piles are used to transfer loads through water or soft soil to a suitable bearing stratum where the type of soil is very soft. In such cases we use end bearing piles. Friction piles are used to transfer load to a depth of friction load carrying material by means of skin friction along the length of the piles. Compaction pile. Compaction piles are used to compact loose granular soils, thus increasing their bearing capacity. See students, see the sketch here. This is a end bearing pile where the soil is very soft. Here it is the friction pile. See this one. So where it transferred the depth of the friction load carrying by means of skin friction. Okay. And similarly for compaction soil where the soil is having loose granular soil. This one, this portion, the soil consists of granular soil and which is very loose and which is very helpful in increasing the bearing capacity. Okay. Next one is pier foundation. So a pier foundation consists of a cylindrical column of large diameter to support and transfer large superimposed load to the film strata below. So generally pier foundation is shallow in depth than the pile foundation. See students, this is one of the pier foundation. I have shown some videos also related to this one, pier foundation, right? Well foundation. So well foundation or caissons are box-like structures which are sunk from the surface of either land or water to the desired depth. They are much larger than the pier foundation or drilled caissons. Caisson foundation are used for major foundation works like bridge, piers, docks, large water from front structures such as pump house. See student, this is well foundation. Can you see the picture? Yes, the construction of well foundation. Next, foundation on black cotton soil. So black cotton soil and other expansive soils have typical characteristics of shrinkage and swelling due to moisture movement through them. It is having a capacity or it is having a typical character of compression and expansion. When moisture enters between the soil particles under some hydrostatic pressure, the particles separate out, resulting in increase in the volume. So this increase in volume is commonly known as swelling. If this swelling is checked or restricted, high swelling pressure acting in the upward direction will be induced. So this would result in several cracks in the walls and sometimes damage the structure like lintel beams, slabs, etc. So during summer what happens? Moisture moves out of the soil and consequently the soil shrinks. So here shrinkage cracks are formed on the ground surface. These shrinkage cracks sometimes are known as tension cracks, are maybe 10 to 15 centimeter wide on the ground surface. So black cotton soils and other expansive soils are dangerous due to shrinkage and swelling characteristics. In addition to this, the soils have very poor bearing capacity ranging from 5 to 10 tons per meter square. So now what we have to do for designing footings of this soil? What are the points to be kept in mind? Let us see one by one. Okay, the self-bearing capacity should be properly determined, taking into the account of the sustained loading. Okay, we have to take into account the loading factor. Then the bearing capacity of this soils may be limited to 5 to 10 tons per meter square. The foundation should be taken at least 50 centimeter below the depth of moisture movement. Then where this soil occurs only in top layer, where where the thickness of the layer does not exceed 1 to 1.5 meter. The entire layer of black cotton soil should be removed and the foundation should be laid on non-shrinkable, non-expansive soil. Where the soil is highly expansive, it is very essential to have minimum contact, okay, between the soil and the footing. This can be best achieved by transporting the loads to the deep piles. Next, where the bearing capacity of soil is poor, or it is suppose the soil is very soft, then the bed of the foundation trench should be made firm by ramming moram. So these are the different process which can be taken into account before designing the foundation. Now types of foundation, black cotton soil. So what are the types? Strip foundation, pier foundation is under-reamed pile foundation. For medium loads, strip foundation may be provided along with special design features. For pier are dug at regular intervals and filled with cement concrete. These piers may rest on good bearing strata. So for under-reamed pile, it is a pile of shallow depth up to 1 to 6 meters having one bulb at its lower end. Now students, for under-reamed pile foundation are bored cast in situ situation concrete piles having bulk shaped enlargement near base. These piles are commonly recommended for providing safe and economical foundations in expansive soils such as black cotton soil having poor bearing capacity. In this type of structures or foundations is anchored to the ground at a depth where ground movement due to changes in moisture content negligible. So a pile having one bulk is known as single under-reamed pile. It is seen that the load bearing capacity of the pile can be increased by increasing the number of bulk at the base. In such cases, the pile is named as a multi-under-reamed pile. So here they increase in the bearing capacity of the pile and also can be achieved by increasing the dia and the length of the pile. See students, this is single under-reamed pile. This is double under-reamed pile. So here what they do, the method of construction of under-reamed pile is very simple. The holes for casting piles in the ground may be bored by using hang augers. Yes. After boring, it is carried out at the required depth. The base of the bore hole is enlarged in the form of a bulb near its base by use of a tool known as under-reamer. So after the pile holes are ready for concreting, reinforcement cages are lowered in the holes and concrete is poured. The pile should be cast at least 200 to 400 mm over the cutoff level. Later on, when the concrete is hardened, the extra length of the pile is broken and the pile top is brought to the desired level. Besides this, beside relative saving in direct cost when compared with conventional isolated footing is poured, it is possible to have overall saving in time of completion of the work by adopting under-reamed piles. Here is the sketch. See students, this is black cotton soil, this is superstructure, finished flooring, and this is the pile cap 1, 2, 3. So here see student, this is single under-reamed pile, this one. This is multiple or double under-reamed pile, this one. Yes. Okay students. Thank you.